Welcome back, everyone. Looks like we can get started today. Oh, before I forget, let me try to pass back these quizzes one more time. Connor? Jasmine? Allison? Ainsley? If I didn't call your name, that probably is assuming that you sent your quiz through email, which in case I would have responded right back with you with your graded quiz. Well, any questions, folks, on the return quiz or other questions at the moment?
Any other question about
The chapter 3 right here, or sure, go ahead. Yeah, we started this one before we went on to the weekend on Thursday, but we didn't get too far. We'll try to refresh what we did before we jump in. Gotcha. Sorry about that. Other questions so far? Okay, well, I do have a lot of announcements to talk about this time. Well, not tons, not like the first day of class level announcements, but we're on chapter 3 right at the moment. And exam 1 is next Monday, so that definitely feels like there's some relationship there, but with the way our schedule is working, I feel like the best way to put the content on for the first exam will be over these sections right here specifically. So chapter 1 to start, and then we ended by finishing chapter 2 last week, although we did get into chapter 3 just a little bit. That will be the coverage for exam 1, since that gives us enough time to actually complete the homework questions in there, do the quizzes, get them returned. Gives you enough time to actually ask questions about any of one of those sections that you may have. And as far as what will be on the exam, hang on, let me say it a different way. As far as what you're allowed to bring to the exam, it will be in this classroom, and you can have a single page of size 8.5 by 11 inches, so your standard letter size, with anything you'd like on it, front and back. You can have it handwritten, typed up. It's completely up to you how you'd like to support yourself. So everyone has to have their own set of notes. They're not allowed to be shared. But this is actually a pretty good process in of its own right of just studying for the exam. It kind of forces you to look through each one of these sections and decide what definitions, what kind of things or formulas you want to really include on those notes. But keep in mind, when it comes to formulas like these ones, you don't have to necessarily put those on your page of notes. Instead, what you might want to put down is, let me try again. Instead, what you might want to put down on your notes is things like this. Steps on what to do on the calculator to calculate certain things like the sample mean, the sample standard deviation. It's hard to draw this out, but you can at least say, press this button, then this button, and so on. So that'd be a great addition to your notes as well, since our exams are in part conceptual type questions, but also in part they're just brute force computations of finding the mean and standard deviation and such. So that's what I would put on the notes as myself personally. And on this exam, we do need a TI-84 calculator. There won't be a ton of calculator work, but there'll be a couple things we have to calculate. The sample mean, sample standard deviation, for example, would be likely candidates. You should also be ready to go for the median, interquartile, quartile 1, quartile 3, and so on to calculate interquartile range if it comes up. And that would be a great support, having that kind of calculator. Understanding how to use a calculator is part of the exam, but you don't necessarily have to have specifically the TI-84. If you're using a different calculator, then it works for you, you've learned how to use the steps, then that's completely fine as well. It can't be a cell phone calculator, that's really the only requirement. So that's my spiel so far. Any questions about the exam at the moment? Okay, so it's a 70-minute timed exam in this classroom, but I'm not trying to write an exam where you have to be writing for 70 minutes straight. Your hand would get tired, it'd be pretty rough. Really what I'm trying to write is about a 50-minute exam on average, so that there's extra time to check your work. It's not really a long exam. I think I have about 6 questions on there. I wrote it on Sunday, I already forgot. About 6 questions, give or take 1 or 2. But it's really gonna just be highly similar to what we were doing in class. Your quizzes, quiz 1, quiz 2, on their own, make great exam questions. I'm going to post a third quiz here that would be due on Thursday. But if you do that quiz a little bit earlier and send it in to me, I'll grade as fast as possible and give you feedback on that one. It'd be very helpful for the second exam, or excuse me, the first exam as well. Then other things you might want to do to prepare for this exam is take a look at these documents. I gave a little bit of a description of what these are. So the sample exam 1 problems version 2, this is the blank lecture notes. Not exactly. If you open this up, what I've done is I've taken the original blank lecture notes, exactly the ones that's in this file right here. And I took out all of the formulas. I took out the examples I felt like didn't make good exam questions. Maybe they were a preview type example or something like that. And I just got right down to the questions. So there's no formulas in here, there's no definitions. But in that way, if you study these problems again, a second time, it's a pretty good honest assessment of how familiar you are with this type of material. So it just goes on a section or chapter basis and doing the same kind of things that we did in class. The downside of this is that you've done these problems before, so they might seem too familiar. So if they're too familiar, you can go to this version, version number 1. Here, these are the new problems and their solutions at the very back. If you open this up, pretty much this could have been the lecture notes, but it's like a second version of the same kind of problems. All these problems would make great candidates for real exam questions. Also, as you're scrolling through these, it kind of does feel a little bit overwhelming. I mean, this took up a huge part of the page, so that's 1-page problem right there. Same with that one. But another thing about this is I can't ask every single one of these questions. That's just way too long of an exam. I can't necessarily hit a question for every single section on every exam either. I think on this exam, I might have a question from every one of these sections, but it won't be every single thing. So think of these review exams, these sample exam problems, as kind of like an exam bank in a certain sense. It's just giving you an idea of what the fair exam questions are, then you get a chance to practice them, and you can look down below here to see what the solutions would look like. If you're looking on version 2, where it's the blank lecture notes, you would find your solutions just by going through the Moodle website, clicking on the relevant section, and taking a look at those solutions there. So that's my spiel so far for the upcoming exam, number 1. When we meet on Monday, September 16th, a week away from today, that's pretty much all we will be doing. Any questions at all at the moment with that exam? Okay. First exam is always kind of stressful because we're just figuring out what does an exam even look like based on what we've done. But keep in mind, it's going to be highly similar to what we do in class every day. The moment I write an exam question, I look into these documents. I make sure that it's something we actually did in class, then starting to look like a good exam question. If it's a question similar to what's on here, it's looking even better. And if it relates to a problem that was done on the actual homework system up here, then I consider that an excellent exam question. I try to write exam questions that hit all 3. Stuff you've done in class, stuff you've done in homework, as well as stuff that's on this first version of the exam problems. So that's where our first exam will end up into section 2.5. But then this is where we're in a really awkward position in this class. The class has to keep on going, so we'll be in chapter 3, not on exam 1. This is now exam 2 content. We'll be working through chapter 4 on Wednesday's class, possibly on Thursday. But one thing I would invite you to do, we don't have a full and ordinary review day for our exams in this class. But if you have questions on Thursday, whether they're from either one of these documents, a problem in the My Stats lab, I'm happy to start out class just taking a look at those questions. So we can have an informal review day in a sense if we have just a lot of questions on Thursday. Well, that's my entire set of announcements. That took almost 10 minutes. Any questions at all, folks, at the moment? Okay, so when you get a chance, take a look at these documents here and here. And if you have questions about them, please bring them to class on Thursday. I'll be happy to discuss those problems further. But here's where we're at so far. Chapter 3. Let's pull out the calculator in case we need it. Move that around. There we go. So we started these notes towards the end of Thursday's class, but we didn't intend to get too far. What we looked at for the definition was the idea of a contingency table. A contingency table displays counts, or if it's a relative frequency contingency table, it would give you percentages. Looks like we have counts on this one. But the major thing about a contingency table is you're dealing with two or more variables. So that's what we were looking at in this problem. A refresh on the study was, this is based off a study in the University of Texas Southwest Medical Center. They were examining whether the risk of hepatitis C was related to whether people had tattoos and where they got them. We made a big deal out of that word. They're not saying that the tattoos caused the hepatitis C or vice versa. So there's no cause and effect here. They're just wondering if there is a higher chance that if you're in one category, you might be in another one for hepatitis C or no hepatitis C. So they had 626 participants in this study. That's the grand table total right here, 626. And all we did to start off, part A, was we looked at the variables of the study. Well, the individuals was a sample, the 626 people in the study. But we defined two different variables. One was called tattoos, or we just called it tattoo simply. And it had three different outcomes. You could have gotten your tattoo at a parlor, somewhere else, I guess a home garage or something like that, or you didn't have a tattoo at all if you were in the study. The other variable, hepatitis C, came from here. That's also a categorical variable. Its categories are you either had hepatitis C or did not have hepatitis C. So in chapter 3, if you're dealing with a table that looks like this, the big takeaway is you're looking at two categorical variables now. In chapter 5, we'll change this all around and look at two quantitative variables. That's where we'll get into scatter plots and such. But any questions so far, folks, with part A of this problem? Okay, part B is asking about a marginal distribution. So let's look at the definition and get the essence of that next. When they say a marginal distribution, it has to happen in a contingency table, and it's the distribution of one variable alone. One or the other. It says either variable alone is referring to a marginal distribution now. So in other words, if we want to take this table, two categorical variables in the contingency table, and just look at the marginal distribution, that means you're just talking about tattoos alone, or you're talking about hepatitis C as a variable alone. You have to extract it out of the table, so that's what we're going to do in the next problem. Let's take the screenshot here so we don't have to scroll up and down to see the table. And I'll park it just right here for easy reference. So when it says find the marginal distribution of the variables, here, I think the parenthesis variables was just not to spoil part A, the fact that there's actually two variables, but it's less valuable right here. So if you wanted to just delete that, scratch it out, I think that'd be just fine. So if there's two variables, tattoo, then we can say tattoo and hepatitis C. We can start by saying marginal distribution for, let's go down below and write out tattoo. And on the right, hepatitis. I guess we call the variable hepatitis C, so I'll stay consistent with that. So if we're dealing with tattoo as a variable, that means all we care about are these categories. Let's take a different color pen. We're not worried about any of this. That's about hepatitis. We need these counts right here. So that's going to give us our marginal distribution for tattoo. We might as well take the total as well. If you skip the total at the very end, I would say that's a big deal. You'd still get full credit. So our table now looks like this. We have a category of parlor, a category of elsewhere, and a category of none. And let me see if I can fit a total in there. And here's the category for total. Next, we just take these counts right here. There was 52 tattoos done at a parlor. There was 61 done elsewhere, 513 for none, and a total of 626. So I would give full credit for this table, but in all honesty, I think I would want to change it just a little bit. Sorry for folks working in pen. I think it's kind of nice to put tattoo right here. So there's the variable, the categories are below, and this column is called frequency. Since that's what we would have called it in chapter 2, section 2.1, when we were dealing with one categorical variable, we were looking at this, a frequency table. You could turn it into a relative frequency table, look at bar charts and those kinds of things. But this is what we mean by marginal distribution. Does that make sense to folks so far? Okay, let's do it again. I'm going to put down below here, hepatitis C, frequency, and same as before, except let's look at our table again. Now, if we're doing the marginal distribution for hepatitis C over here, that means we don't care about tattoos this time. So let's wipe out all that. None of those counts actually matter. We want pretty much just this. We wipe out everything going horizontal. If we're doing it for hepatitis C, we just care about the 47 that had hepatitis C, the 579 that did not, and the total of 626. So that's how the data would come together on this one. Let's go hep C, just to abbreviate. No hepatitis C, hep C, total. And that gives the numbers going along these column totals. 47 people in the study had hepatitis C, 579 had no hepatitis C, and same table total, 626 participants. So we did it, folks. That's what we mean by marginal distribution. In a marginal distribution, all we're really trying to do is take the contingency table with two categorical variables and view it as one variable or the other separately, all on their own. Any questions at all, folks, with that portion there? Okay, so far everything we've done on this problem has just been more about definitions. But if we return to what was going on with the original study here, it says we want to know if hepatitis C is related to whether people had tattoos and where they got them. We still haven't really hit that part of the problem, but that's what the next follow-up questions are now starting to be all about. Analyzing that two-way table and seeing what's going on with the two variables as they relate to each other. First, we want to take a look at a conditional distribution. The definition's up above, but in an attempt to not scroll up and down so rapidly, here's the idea with conditional distribution. When you're looking at a conditional distribution, it means you want to know how does a certain variable, like hepatitis C, relate when you're only looking at one category of another variable, like whether they got the tattoo at a parlor and so on. Let me put this down here just in case we need an extra one. So if it says, what is the conditional distribution of tattoo, given that the participants have no hepatitis C, it means we are really right here. This is our whole reality in that location. So that means the counts that go this way and this way are irrelevant to us. This will be the conditional distribution of the tattoo given no hepatitis C. This is a weird way to write the answer, so let's actually draw it out. Over here, we'll go tattoo. Let's capitalize it maybe. Going this way, it'll be frequency. Then we put down the categories. They were parlor, elsewhere, try to make those bars a little bit more horizontal. Really hard for some reason. None. And total. So when I'm answering this question here, it's going to look kind of crazy in the notes. I actually want to leave this graphic right below. But the reason I'm mentioning this is when you go to actually solve this, whether it's a quiz or exam problem, you don't have to do that. The table is all you need right here. If you see extra graphics with drawings or highlighters on them, it's just the extra explanation on the notes. So the total answer to the question is whatever we put here. Double checking what they told us, we want conditional distribution of tattoos, given that we have no hepatitis C. So we go to only that column, and this is the data we use. 35 hepatitis C people had it done at a parlor, 53 elsewhere. 491 people with hepatitis C did not have a tattoo at all. Notice what's also happened. When you look at a conditional distribution, your table total has changed. Everywhere else, it's been 626 participants. But if we're restricting to no hepatitis C, the total is now 579 participants, which can be a bit of a surprise, but that's what we mean by conditional distribution. We're reducing the study down to one slice that we're interested in the most. Well, at least for part C. Any questions, folks, about the differences then between conditional versus the marginal? Okay, these are kind of cool questions in a way, but as far as like a real exam question would go, it wouldn't be directly this kind of stuff. This is more just getting practice, understanding the table and the information. There'll be a couple of homework questions along these kinds of lines as well. So that's another reason why we're looking at them. But the kind of questions that you might see for real exam questions would be more similar to what we have going on in part D next. So here's our next portion here. Part D asks an important question. What percent of participants have hepatitis C? Like before, I'm going to copy the table down and paste it down over here, only for the purpose of highlighting, if you come back to the notes, how we answered the question. So I'd mention this a lot because some people have actually copied this down to answer the question. You do not have to do that. That'd just be way, way too much busy work, writing that down on every part.
47 is divided by 626.
Absolutely. I like the 626 thing you mentioned, because to me, that's going to be the trickiest thing about all of these questions. When it said what percent of participants, it's referring to the table total 626 have hepatitis C. Well, there's 35 done at parlor, 53 done elsewhere. Oh, I'm on the wrong column. Let me try again. Having hepatitis C is over here. Hang on, let me double check. Okay, I got a little confused. This one was no hepatitis C. This question is hepatitis C. That was my conundrum there. There's 47 of them. I'm sure you could add all these up, but it's already been totaled. So we just do this. 47 divide by the table total of 626. And once a percentage by this indication to the nearest tenth of a percent, so you'd also want to multiply that by 100%. So that's probably how I would write it down on paper. Back in the calculator, it goes like this. 47 division just gives that slash. I think that's a forward slash. I forget the difference. Divide by 626. And the times 100 is just so we don't have to move the decimal point by our eyeball. The calculator is just going to do it for us. So kind of optional if you want to do that part. Gives me 7.5% to the nearest 10. So we'll just put down here 7.5%. So not even 10% of the study had hepatitis C, but that's probably because it is a rare condition. It's a very serious condition. That's probably a good thing. They couldn't round up too many people with it. Any questions at all, folks, with part D? Okay, I want to write down an extra comment on here that I'll come back to a lot in this class. It's all about partial credit. This is an exam 2 question. It's not going to be on exam 1 is what I'm meaning. But here's what could go wrong on a question like this. Let's imagine you didn't put this down at all. You gave me a number, say like 17.8%. If that's the only thing that you had on your exam, then you could lose all the points because there's really no basis for partial credit on that. It was probably just a weird calculator mistake, right? You probably knew the numbers, but I personally can misclick just with fat fingers and get the wrong numbers. But if your problem looked like this, you showed me what was about to go into the calculator, just writing it down on paper, but you got the wrong number, I would give essentially almost all of the credit on that problem. If it's a 4-point problem and your number is way out of spec, I'm going to look at this and just say, well, you've got the right stuff. It was a calculator mistake. I'd probably give 3.5 points out of the 4 points total. So the more you actually write down on paper, the more ability I have to award partial credit on these kinds of problems. So that's just a quick blurb of something that I want to probably mention a few more times, just as a reminder. But now let's go on to the next one. Any questions first at the moment? Okay, so new table. We've got it down here on part E. Let me move that off to a new page. Next question says, we move the table over first. What percent of the participants have hepatitis C, but have no tattoos? Well, if they say, what percent of the participants, we're still using this 626 in the denominator. But you want to see what the numerator should be on this one. I think it's a little bit trickier. Have hepatitis C, but no tattoos.
410.
Yeah, no tattoos would go this way, right?
Half of it.
But if it says has hepatitis C, it goes that way. And we're looking at the intersection. Does that make sense to folks with that one there? In other words, you could rephrase this. This could be rephrased as could be rephrased as I think I forgot how to spell rephrase, but we'll just try again. Could be rephrased as has hep C and no tattoos. So if you see it phrased that way, it'd be meaning the same thing. You have one condition at the other, all at the same exact time. Only 22 people fall into that category. And so we would grab that count there. Awesome, let's go times 100. And 3.5%. Well, does that make sense to folks on how we got the numerator this time? Okay, I think the way I highlighted is kind of weird. This was the idea. Let me reverse engineer that, just in case that looks funky. When it says have hepatitis C, I visualize going down these data. When it says have no tattoos, I go to the none column and go this way. But I just grab the data that's in the intersection. So that's usually the way I think about it. But looking at it, it's going to be kind of crazy if I leave it that way. I'll just go like this maybe, so the notes don't get too wild looking. So that's how we put those two numbers together. And now let's try it again. Any questions at all, folks, with that 3.5% first? Okay, let's look at this again. They said, this is the percentage of the participants that have hepatitis C, but no tattoos. That's interesting because we're looking for a relationship between the two. This one came out as a small percentage. And now the questions are starting to refine even more. Let me take this and move it over as well in case we need it. So here's our part F. What percent of the participants have tattoos? This one's a different computation too, but it did start by saying, what percent of the participants? That's always a good thing to look at because they're talking about the denominator now. 626 participants in total. But now we have to deal with have tattoos. What values would you folks put in for that there?
It's just asking for the total.
You're on the right track for sure, yeah.
That would be 50.
Yeah, it'd be the 5261, but you're on the right track for sure. When it says have tattoos, that's really confusing because that's two categories of the tattoo variable, referring to at the parlor, elsewhere. And there's two ways you could have those tattoos. So there's like 4 counts altogether. But as Pope folks said, you go here, you're reducing the work by quite a lot. There's already a row total. So you could just go 52 plus 61 times 100%. This is kind of tricky to put in the calculator all of a sudden. Let me put it in incorrectly. Tell me if you can spot it, what the problem was in the calculator. When you do this for the first few times, especially using a calculator like this one, there's a real temptation to type in this. 52 plus 61 divided by 626 times 100. But this is actually wrong. If I hit enter here, that's not the right percentage at all. Yeah, that sounds like it's much more correct. I mean, the numerator is only 110 divided by 626. No way that is that 61%, 62%. Anyone see what the problem is in the calculator? Exactly. Order of operations is what went wrong. The whole numerator here is really considered a group by order of operations. And I usually don't put parentheses around that, but you know what? It doesn't hurt. It just reminds us that in the calculator, you really need to wrap parentheses around that. So if we try again and go parenthesis, 52 plus 61, then division by 626 times 100, just so we don't move the decimal place over. Then the calculator is going to do the addition first by order of operations and then divide. But up here, if you're following the PEMDAS, calculator is going to divide first because division takes precedence over addition in order of operations. So parentheses are telling it to add first. And that gives us 18.1% after rounding.
You can also do almost like there's 2 parentheses at the beginning and then close it after 626, so don't do that.
Well, that's kind of cool. Let me put this in and go, oh, once I get that to work, 18.1%. And you're saying 2 parentheses at the start, then 52 plus 61, close, divide by 626, kind of like that, you're meaning? Yeah, that would work out excellent as well. Times 100, and we have the same value. There's another way you could do this as well. I like putting everything on paper into the calculator in one line. It's just the way I like to do it. But folks might have a different way you'd like to calculate. Different way to do it is just do order of operations yourself. You know you have to do 52 plus 61 to start. So go 52 plus 61 and just hit enter. There's your numerator, 113. You don't have to copy it on paper. You don't need to show me the steps. Divide by 626. Notice the moment you hit division, it says A and S. That's referring to the prior answer, 113. So we're dividing prior answer by 626. We're at the decimal version, converted to a percentage by going times 100. So you can do it in stages, and honestly, doing it this way in stages is just as fast as typing out the whole answer. So I would suggest find a way that you feel the most comfortable with and just stick with it. You'll be in great shape. But we did it, folks. That's part F. What percent of the participants have tattoos? Almost 20% of the study. So hepatitis C is not represented by a whole lot. Neither is tattoos, but it's the data they had. So we'll keep on going and see what's going on in the next question. I apparently had a typo. I don't think I had the word have in there. It read, among those who tattoos. And I just found this before class started. Sorry about that. So if you printed this out already, please insert the word have or something like that. So part G says, among those who have tattoos, what percent have hepatitis C? This is actually a very different kind of question out of nowhere. We're not dividing by the table total 626 any longer. So let's go and change this up a little bit. Well, I think we could fit it on this page. When it says among those who have tattoos, the region that we would have to highlight is here. Exactly. We're only talking about those people. It's as if no one else in the study actually matters any longer. It's all about them. And if it helps, you can take, say, another note card to cover it up. Maybe you have a highlighter or a black pen, you can get rid of it, but that's kind of a permanent step. But just to emphasize on our problem, this is all we care about, the 52 and the 61. So it says, among those who have tattoos, what percent have hepatitis C? Or they're talking, sorry, say again? Yeah, it'd be the total of those two, exactly. And it doesn't seem like it's totally correct, but you're on the right track, absolutely. Because we're losing all that data, right? But when it said among those who have tattoos, it's like the conditional distribution. Now, this is the only part of the table we care about relative to that question. So we do the 52 plus 61. Those are the people, only the people who have tattoos now. Having hepatitis C is the 17 plus 8. Then times 100%. Now, if I was to put this in the calculator in one line, I would go like this. Parenthesis for the numerator, 17 plus 8. I could add that in my head, but I make mistakes in arithmetic when it's late at night, especially. So at least I feel confident I have the right thing here if I typed it in right. Divide by 52 plus 61. Notice I need parenthesis for the denominator as well. So both of those have to be put together. Then just times 100. That gives us a percentage of 22.1% altogether. So already this is kind of interesting in a way, right? Let's look at the prior question. What percentage of participants have tattoos? About 18%. Let's look at the other one. What percent of the participants have hepatitis C, but no tattoos? 3.5%. Now, if you were just looking at the people with hepatitis, or excuse me, if you're just looking at people in the study with tattoos, the percentage of hepatitis C has jumped to 22.1%. It looks like there really is a relationship just by looking at those numbers. And again, these questions are just about looking at how to dissect the table to get the right information. Let me see if I can fit that at one page. Hey, it fits. Any questions at all, folks, with part G? Okay, in my opinion, part G and H are the trickiest one in this whole set because the denominator is now changing a whole bunch. And it looks like we're kind of about done with those kinds of questions. One last one with part H. Now it says, among those who have no tattoos. So now, if we're talking about those with no tattoos, we don't care about any of these people any longer. We're in this part of the table. In fact, the total on this row is now just a distraction. Our whole focus is here, among those who have no tattoos. The new total is 513, so we'll put the 513 here. Does that make sense to everyone and how we got that denominator? Okay, always looks kind of weird. And honestly, if you're doing this problem in an exam setting, just a couple note cards you're allowed to bring to an exam could help out with just kind of zeroing in what part of the table you're really looking at. For me personally, whenever I see data like this, just all the numbers, it gets kind of disorienting and distracting. Anything you can do to just even highlight to direct where you're at really pays off for these kind of questions. So we got the denominator among those with no tattoos. Now we need the question. What percent have hepatitis C? So we're only in this location. I shouldn't have highlighted those. Let me go that way. We're just grabbing the 22. So multiply by 100%. No weird order of operations issues on this one, just 22. 4.3 things. We should get a 4.3%. Awesome. Well, any questions, folks, with that one there? Okay. Purpose of all these questions up to part H, where we're doing these percentages, is, again, just another way to look at the table and seeing how the information combines. Because if you go to a frequency table, like this one, they're not too bad to understand. But if you go to a conditional table like this, where there's two variables all at once, it is hard to really see what's going on. So the purpose of all those questions is just to dissect the table. But another thing is, we're later on going to say this. This is basically an introduction to probability. You could have changed this whole question and said, what is the probability of having hepatitis C, given that the participants have no tattoos? And you would have said 4.3% or 0.043. Usually probabilities are given in decimal form instead of percentage, but it's the same exact quantity. So if you're thinking about probability being a crazy section, we're kind of doing it right here. It won't be too bad, I promise. We'll get through it. So going on next. One thing you might have had as a complaint about this table is its frequencies. And with the counts of 626, oh, I lost my table. Let me grab it again. Way up here. With a table total of 626, some of these percentages might be more shockingly different than the counts would have really indicated. So if we can convert these to percents, they might make a whole lot more sense. But there's several ways to do that as well. We take this here and copy it to our last question. Part A is saying, create a new contingency table using row percentages. Here's the original percentages, and just in case I need extra space, let me put some extra space here. I have a tendency to write kind of big. So with row percents, what we're using are these counts as the denominators in our calculator. And it's really not too bad. We go to these counts here. It is a little bit tedious, so that's the downside of it. We're going to go to these counts, divide by the row totals, and just insert the percentages. So computations are going to look like this. I'll go row-wise. 17 divided by 52 times 100.
17 times 52.
Oh, geez. Yeah, that's way off. Let me see if I can fix that. Up arrow, enter, and throw a division right there if you made my same mistake. So we're at, let's see, the nearest 1/10 of a percent. That'd be 32.7%. So that would go over here. We already know this total. If they say row percents, this would be 100%. I'm leaving off the percent symbol just because I'm writing quite big. I can't fit it in. That'd be okay as well if you were doing that on your own work. This would be interpreted as percentages now. So I'll always have 100% going this way. And now it is tedious to calculate these, but if you wanted a number right here, there's another way. You could just go.
Why did you 100? Yeah, why did you?
Sorry, go ahead.
Why was it divided by 52 and not 600?
Oh, only because of their saying row percentages. So we want the percent of just out of the 52 people, how many had hepatitis C, how many had no hepatitis C for the tattoo parlor. So if they wanted a table that was using column percentages, it would have gone this way. Or like you're mentioning, you could have just taken this and divide everything by 626. That would have been a full-on frequency table in that case. But this one just wants percentages this way. You might ask, why in the world would we want that? The reason is we're going for a segmented bar chart, this thing down here, which uses column percentages or potentially row percentages. Does that make sense for that question there? Okay, and yet just to mention, if you converted everything to percentages, but divide by 626, that's just as good as the other two tables that we'll be looking at on these notes. The only side effect is it's hard to produce graphics for that one if you're looking at a segmented bar chart. But now going over here, to save a little bit of time, what you could do is go 100 minus. The shortcut is you don't want necessarily type that out, or you could type this in if you want to not have to round. I'll go this route. Second, negative sign to pull in the prior answer. And I get 67.3%. points after rounding. So 67.3 going this way. Then we just rinse and repeat on the next row. On this row, we'd be taking 8 divided by 61. Then multiply that by 100. We've got a percentage of 13.1 going this way. Then either take 53, divide by 61 times 100, or just go 100 minus, hit the second button and the negative sign for prior answer. And we get 86.9% after rounding. That look right to folks so far? Okay, it's definitely tedious, so I won't ask a lot of questions doing this kind of thing, because I realize it does take up time. The row total here is 100% as well. Then we have 2 more rows to go. Next one is 22 divided by the next row total, 513 this time, times 100. And we get 4.3% on that one. Then go 100 if you're taking this shortcut, minus, different way you could do this in the calculator is up arrow, hit enter, and that's just a different way to call the prior answer. Whichever way just feels faster is what I would stick with. Now this comes out as 95.7%. Yeah. Only if you're doing row totals, yeah. It says row percents rather. You'll always have 100 going this way, yes. One way that would be off is if I rounded a little bit weird, and maybe it's like 99.9%, but I would still give full credit to that. Any other questions so far? Okay, last one. Let's even take a look at these totals going this way. So 47, now we're dividing by 626. That gives us a percentage of about, what are we rounding to? The nearest 10th of a percent. Oh, I forgot to hit times 100. Not that it's required, it just is easier to visualize in my opinion. 7.5% going this way. Then 100 minus, I'll do the up arrow trick again. It feels faster, at least if I'm clicking with the mouse on the keys. And that comes out as 92.5%. I would 47 divided by the 626. So I'm looking at this number here, divide by that row total, 626, which happens to now be the table total at this point.
So would we be able to add up, if we wanted to stick to the percent, could we do 32 plus 13 plus 4.3 over 100? Would that be the same thing or no?
Not if we're doing row percentages. So these would not add up to 100 any longer. The way they add up to 100 is only going row wise like that.
So when we do row percents, we can't use any of those numbers per column, right?
Which numbers here? These,
So
right,
we're
yeah.
We're doing that table, we can't use any of that information for doing the column table.
That's correct, yeah. We couldn't get, say, the number 7.5 by looking at those numbers. Is that what you're meaning?
Yeah.
Yeah, that's absolutely right. We have to constantly go across these rows, do the divisions. Let's put down that last 100 right here. Other questions, folks, at the moment with this? Okay, and it always deserves repeating. Why not just divide 17 by 626? Get all your percentages. That would work. You'd have 6 different percentages here. They would all add up to 100%. But the downside is this table here, whether it's percents or counts, it is really hard to give a good bar chart to that, unfortunately. But if you're doing a table that looks like this one, using row percents, it's not as hard to give a graphic to that. The ones that I actually give a graphic to is the one going column percents. So if it's column percentages, what you're going to notice is you now have 100% here, here, and here. And the way we found these numbers was, oh, I should bring that back just for a moment. Oh, geez. There it is. The way you get these percentages right here now is, let's see if we could get the 36.2, for example. We would put 17 divide by, if it's column percent, we'd go to this column total, 47 times 100. That gives us 36.2%, and that's how these are coming into play. So if it's a column percent, you're dividing by these values here. Other questions so far? It's kind of the opposite of this way. Here, the rows will add up to 100%, but if you're doing column percentages, this way they add up to 100%. Exactly.
It's not like you're pretending that the totals at the bottom are just another category.
Absolutely, yeah, it's a good way to say it. And the prior problem, we're pretending like the rows on the totals on the row were the sum for the whole category. Let me see if I can move these up now, so we can see both of them at once. So whether it's row percents, you're going to be having 100% going row wise, but if it's column percents, you'll have 100% going down column wise this way. Again, pretty tedious to build out these tables, but other questions so far?
So the bar chart was flipped, so it would be the bar chart, you know, sideways like this, would it be the top one?
For the top one, yeah, it'd be essentially not exactly the same kind of shape. You would have, let's see here. Let me think about that. That's a really good question. What would the segmented bar chart look like for this one? See if I can move this to the left. We would still have something that goes this way. So it'd be from 0 to 100%. Let's see, if we're going this way, for row percentages, the major things we're comparing is hepatitis C versus no hepatitis C, excuse me. And then we're going to take, say, 32.7. Let me see if I can build this. So this is going to be tattoo at a, or hang on, hepatitis C, no hepatitis C. And now we need a different legend. I'll go like this. Tattoo at a parlor, tattoo elsewhere, none. That's going to be the dual to the legend going this way, where I had just two colors for the two categories of the hepatitis variable.
32% purple, and then you do 13% in the blue, and then 4.2% in the green, and that should be, and that would all be 100%.
Exactly.
Oh, yeah.
So let's see if we could draw this. This is the challenge now. Sorry, say again? Let's see, I'd have to go.
Shouldn't those three add up to 100 though, in order to do it? You'd have to do,
Oh, hang on. Yeah, hang on.
you just have to do one bar with Pepsi and no Pepsi, right?
I'm getting a little confused on that.
Yeah.
So with hepatitis C, no
Then you
hepatitis.
have the no Pepsi is like 68, then 86, and 95%. You're trying to,
Yeah.
you're trying to do the colors of the tattoos and not, you put the, but you can't do the colors of the tattoo, or you can't do the colors of the tattoos for two categories. So how would you map that out unless you did, the way they did at the bottom of the display results, you can just flip them. So rather than the hepatitis B and hepatitis C on the bottom, you do no Pepsi on the bottom. That's the only way I see that graph. So.
Well, I think what would help me out, at least personally, is let's take a look at this graph first, then see if we can reverse engineer how to produce the one here to address your question. Does that work out?
Yeah.
Okay. Well, looking at this graph here, this is based off column percentages, so they should total to 100%, right? And let's see, the legend is hepatitis C, no hepatitis C, 3 different categories. They're talking about those 3 there. So now on this one, tattoo done in a parlor, we're just looking at those percentages going this way. No, hang on. Tattoo done in a parlor.
I think they did the row percent on that graph and then put it.
Yeah, I think you might be right. I might have the wrong graphics on this one. Should have been. Oh.
Because that's representative of the row percent.
Yeah, I'm looking at my numbers and they don't seem to quite represent well. I see what you're saying.
It would be more sensitive they did the column, like, if they were to make that graph for the columns, they would do hepatitis, no hepatitis, and then you would see three portions in those two.
Yeah,
That would be
that's
how-
why I was a little confused.
Yeah.
Yeah, I feel, I see what you mean now. So putting it right here, let me see if I could just move it side by side. Or does it want to move? We can make it move, but let's settle with it right here. So we have hepatitis C, no hepatitis C. Let's see these percentages. First one is tattoo done in a parlor, and that's represented all the way at 80%. Oh, hepatitis C rather is represented,
Yeah,
huh? My numbers seem a little bit odd on this thing.
I think the numbers are to that one.
Sorry, say again?
The numbers are to the question. Well, I think it is, yeah, because you see how it says, like, your farmer and then. No.
Yeah.
Or, well, no.
No,
because
because
the
the
number
number
is
is
32.
Definitely, it's a good problem for healthy debate. I think we could all agree on that one.
I don't know whether that's at 80%, you would have to.
You're right.
Because the,
That's what I'm
Yeah.
curious, where did you get the 80?
Yeah, I'm looking at the same thing and I'm wondering if I just have wrong numbers on this one. This already is kind of, sorry, say again?
but all of the columns line up to 100. Yeah. So all of the blue and orange should counteract each other to be 100, not to graphically don't.
Says here's the contingency table again, using column percentages as well as a segmented bar chart. But I think looking at that bar chart, if I looked at just that category, seems to fit this the best, right? Those numbers there. Tattoo down on parlor has hepatitis C, but my category is a little too high here. I think my numbers are just wrong on that bar plot right there. I might have to fix this.
Sorry.
No, I'm glad you pointed that out. It looked good at first, but
So where do you
my
look at?
numbers don't seem to correlate with either table. This might be a come back to type of question right here. So I'm really not too sure how I got these numbers any longer. Huh. Let's look at maybe,
Well, I wonder, because that's not the none. Got the 81.
we're focusing on none,
I know, I was just looking at the total.
then that's about at height like 30%, right? And it would say the blue here is hepatitis C. So let's go back. None at hepatitis C. It should have been higher. It should have been at about 46%. So yeah, I think I just have the wrong table on this. It was almost close. Maybe I changed some numbers or just had an error in Excel when I produced it.
It might have not the graphic first, like scan past it, now we're actually looking within the graphic. Like,
Yeah, let's see if we can maybe get this to work. Let's go to Excel here. This is how I produced this, and
yeah,
let's see if we can potentially fix it. I won't waste too much time if this becomes untenable. But here's our data so far. We just spread that out a little bit. Now, if I want to get graphics on that, I probably want to go to, or what table did I actually grab? Oh, I didn't get the total, but that shouldn't be a big deal. The Excel is going to do that for us. So let's go to, let's see, insert charts, recommended charts. Sometimes does a pretty good job. And I'm going for something that looks,
well,
let me try and get the percentages in. That might help us out. So one last try. I've got the percentages in. It's thinking about it. You can copy paste is a little bit faster. Just go to a new sheet. This one just feels damaged now. Okay, I think we've got the numbers. I think the highlighting was throwing it off. Okay, so everything is in there. Let's go back to recommended charts. And I wanted a stacked bar chart, segmented bar chart, something like this. Oh, but it has a category total, so that actually didn't help me out. I know we said last try a couple times, but last try.
Okay, we got it. We're so close.
So let's go to recommended charts. It was down near the bottom. So yeah, that looks like the right categories. But is it? Let's put it in our actual document and see if we believe in it. So you should usually just be able to delete stuff you don't want on there, like chart title. I don't think we need that. And let's just pretend that wasn't here. Sorry, say again. Okay, we came back, the colors changed. I don't know how to explain that, but we have new colors on it as well. But let's see if it makes sense, though. If we don't believe in this table, then it was all for nothing, right? Okay, so, sorry, say again? Absolutely. Let me fix this table here. Well,
Yeah.
ah,
That will let you.
yeah, that's kind of upset with us, but I'll come back to that and make it look better. So back to this, if we're looking at hepatitis C, done at a parlor,
That looks accurate, yeah.
uh-oh,
36, yeah, 3%.
column percent. So yeah, this is starting to actually look right. I agree with you. None should be about 46%. So that looks like it's, yeah,
So one of the other chart options for when you were in Excel
yeah,
kind of shows like the 3 bars and the 3 bars. Is it basically just that? It just stacked on top of each other?
yes,
Or each
absolutely.
column?
Yeah, I wanted to stack so that each column represented the whole of 100% was, which was what I was going for.
So if we would, if it makes more sense to us to draw it with those 3 columns per one, could that, would we still be get full credit, or do you want it in that?
I would say either should be fine, but in all honesty, my goal was willingly to produce the graphics and then we would read them and comment on them. This is not graphics I would ask you to do by hand. Yeah. It goes just a little bit too far, I'd say. You practically need a ruler to get them right. But, well, that was a good question. Thanks for spotting that problem with the data. Let's take another look at it because, I mean, if you find one mistake, it feels like you should be suspicious. We have a column for total. Did we need that? We didn't actually even need that, did we? So we could delete that later. Come back to. So I'm going to clean this up a little bit, make this table look more readable, fix the graphics. I'll put some graphics up here too, since why not? We should compare both to see how they go. It looks like I have a little bit of homework on this problem as well myself. Nonetheless, let's see if we can end the class today by answering part K. Part K was asking the question, do these data indicate that having hepatitis C is related to whether they had tattoos? How would folks feel about that? Would you say yay or nay?
Because the majority of the people that had, or the biggest percent of all of the data of all of the people that were tested, didn't have tattoos and didn't have hepatitis.
That is true. So our data has a problem that there is, there,
The other bar chart, yeah, but not this, yeah, so if we were to change the data and only provide people, or only have tested people who did have hepatitis, and then compare it to see who had tattoos and who didn't, that would be able to answer the question, but because you have so many people that don't actually apply to what we're trying to solve. I would say there's a higher chance of you getting hepatitis if you have tattoos.
well, taking a look at where they had
Look at the, first percentages,
up here.
yeah,
So looking at these categories, there is a problem with the data, like you mentioned. Very few people with actual tattoos, very few people with hepatitis C. But addressing this question based off the information that we do have, the data we do actually have, going through tattoos, tattoos at a parlor, tattoos elsewhere, and none, versus hepatitis C. Hang on, I'm starting to get confused on my graphic. So tattooed at a parlor.
yeah, it's just that, one column.
Yeah, it looks like whether you have a tattoo at a parlor or a tattoo elsewhere massively changes the amount of cases of hepatitis C. And that is really weird. So lots of hepatitis C at a tattoo parlor, very little, if it was, or very little tattoos done if you have no hepatitis C at a tattoo parlor, but very comparable here to here. But if we see changes like that, there is a relationship, but it does need a disclaimer, like you're saying. The data wasn't ideal because of the minimal cases for the different categories, no tattoo, people with tattoos and people with hepatitis C.
So to answer that question, you would have to, but yes, there's a relationship between those with hepatitis C and tattoos done in parlors versus elsewhere, but the data is mostly biased. Oh,
Well, the data didn't quite have an even
Yeah, it
representation
is not-
of every category. They took a random sample, it didn't fall nicely. In a way, that's kind of what they might have expected, because hepatitis C is just a rare condition in the first place. But yeah, that's the kind of things I would say here. Let's see if we can make that our final statement. There appears to be a relationship due to the different heights of categories in the bar chart, but the counts were low for tattoos and hepatitis C, which that's the whole study, right? Seeing how they might relate. Let me see if I can get just a little bit more space going that way. Oh, not much. Oh, there's a trick. Let's just put that all the way down. There we go. So we'll say we're low for the tattoos and hep C cases. And so we should be wary of this conclusion. So it does two things. It does address a question, looking at the data, seeing that there's a problem, that there must be a relationship as the counts change, but admits the data is not ideal. So using that conclusion as fact is possibly problematic. So that's about the conclusion I would give for this kind of problem. But other questions or comments, folks, on getting through this question here? Okay, when we come back on Wednesday's class, I'm going to return to this just to try to fix up the graphics, see if we can read them a little bit better, because boy, that was a challenge. And I mean, building the table is challenging too, right? It's weird to do row percents. It's weird to analyze column percents, but that's the purpose, to try to get that kind of plot. So we'll come back to that, then move to chapter 4. Cool.
I just had a little bit of trouble understanding over the weekend more on standard deviation. We go over that just a little bit.
Sure, you're meaning on Wednesday's class or?
Yeah, so right now, like, could we go back on from
Yeah, absolutely.
on Thursday?
So
Like,
that
doing
was,
the, I don't know if it was 2 or it was the homework assignment, but it was talking about standard deviation.
gotcha. What was the question related to standard deviation? Was it along the lines of which statistic to use versus the shape of the data, or is it just calculate the standard deviation?
I think it was calculated and I was confused as to what the difference between that and the IUR.
Oh, gotcha. So the idea with the interquartile range is it does this, takes your 75th percentile, which is up here, your 25th percentile, which is down here, it just calculates the distance of that central half of the data set. So that's what interquartile range does. Standard deviation is a little bit different. What standard deviation does is if your data is roughly symmetric, so you have to have symmetry already to begin with, then take your sample mean, subtract the standard deviation, sample mean, add the standard deviation, thank you. That'll contain about 68% of all the observations. So up on that graph above, that's what this blue line is saying. We calculated Y bar, subtract 8.3, it put us here. Then we did the same, took Y bar at 8.3, we're up here. From there to there, that's 68% of all the data. This was slightly skewed to the left, so it's not perfect, but even if it's roughly symmetric, that's what the standard deviation is doing. It's the central 68% relative to the mean. So if your data is skewed, your mean moves and it becomes less and less a great statement. But if it's interquartile range, that's always just the central 50%.
We brought the range that we had included from 25.7 minus.
Well, this was calculated directly from the calculator. We put in all the data and then we grab this right here for S.
Is that always going to be standard deviation on calculator?
Yeah, the SX.
Yeah, I wasn't calculated I can identify the Q1 and the mean and the important stuff on that first, like when that's shown, some of those symbols I don't understand there. So.
Gotcha.